This is a question on plane and vectors. So, okay, it's given that plane 3 with equation, if this Cartesian equation where alpha and beta are real numbers, the line of intersection of their two other planes is L2. So imagine there are two other planes. Okay, their line of intersection is L2. Okay, so then, and L2 has this equation here, 332 plus mu 2 1 minus 1. This means that 2 1 minus 1 is the direction vector of this line of intersection. So given that the three planes do not have any point in common, find conditions satisfied by alpha and beta. So if the third plane has no point in common, that the three planes have no point in common means that they neither intersect at a point nor intersect on the line. Okay, that means, let's say plane 3 can be the equation of plane 3 can be rewritten as r dot alpha 1 minus 1 equals to beta. Okay, so this is the scalar product form of the equation of plane 3, which implies that this is the normal. This is the normal to plane 3. Okay, if plane 3 does not have a common point with the other two planes, that means the normal to plane 3 must be perpendicular to the direction vector of this line 2. Because if it is not perpendicular, then the plane would intersect the first two planes on this line, and then we will have a point in common. So one of the conditions satisfied is alpha 1 minus 1, the dot direction vector of 2 1 minus 1 will be equals to 0. Okay, so that means that 2 alpha plus 1 minus 1, no, 2 alpha plus 1 equals to 0, and that means alpha equals to minus 1. Okay, so we have gotten alpha. We need to know what is our beta. Okay, so the reason to emphasize why the normal of plane 3 must be perpendicular to this direction vector of this line, because let's say if the plane was, if it is a normal, okay, let's say in the case where it is a normal, that means the normal could be like this or anywhere. Okay, if as long as the normal of the third plane is perpendicular to this line, that means the plane, okay, the plane will not intersect with at a point with the first two planes. Okay, but there's one more condition to be satisfied. The plane cannot be on the line. The line cannot fall on the plane itself. Otherwise, the normal would still be, for example, if the plane was like that, the normal to the plane would still be, if the line was on the plane, the third plane as well, the normal to the third plane will still be perpendicular to the direction vector of this line, but it will intersect. It will have many common points with the first two planes. The entire line will be the common points of intersection of the first three planes. So we could not allow this case to happen where the line falls on the third plane. We cannot allow that to happen. So what we do is to say that R, we substitute the line equation into this, the plane third equation of the third plane. It must not satisfy this equation. That means if I substitute this 3, 3, 2 plus mu 2, 1 minus 1, this R, the equation of this line, into this equation of the plane, right? So dot product alpha 1 minus 1, it must not equals to beta. If it's not equals to beta, then the third plane does not, the line does not fall on the third plane, so the third plane will not intersect with the first two planes. Okay? So to recall, that means if there are two conditions that must be satisfied in order that the three planes do not have any points in common. One of them is that the third plane's normal dot product the direction vector of the line of intersection of the first two planes must be equals to 0. Another condition is that the line equation of the line of intersection of the first two planes when substituted into the third plane equation must not satisfy that equation. So must not satisfy this equation. And alpha we already know is minus 1. So it's 3, 3, 2 plus mu 2, 1 minus 1 dot product minus 1, 1 minus 1. Since we already know that alpha is minus 1, must not be equals to beta. That means 3 plus 2 mu times minus 1 plus 3 plus mu plus 2 minus mu times minus 1 not equals to beta. Okay, so to make space, so then we simplify this. Minus 3 plus 3, so these are two are settled, is 0. So minus 2 mu plus mu is minus mu, minus mu minus mu plus mu is 0. Okay, plus mu, because minus mu plus minus 1 is plus mu, plus mu plus mu 2 mu, 2 mu minus 2 mu 0, and then we have 2 times minus 1 is minus 2. So beta must not be equals to minus 2. So this is the conditions for satisfied by alpha and beta, such that the three planes do not have any points in common.